Scott Kelly, Sam Champion, very nice to talk to you. How are you doing?
Hey, I'm doing great. Good to talk to you this morning.
All right, I'm just checking the delay a little bit. So Weather Channel loves to cover space, so it may seem like I hit a couple of topics with you this morning, but I see us as using this in many places. So we'll start in one direction, and then we'll ask you about the health experiment, if that's okay with you.
Absolutely, yeah. There seems to be a little bit more of a delay than normal, so we'll have to just deal with it.
That's all right. We'll edit it, sir. So really nice to talk to you. Astronaut Scott Kelly, hey, let's talk a little bit about the breaking news of the day today. So New Horizons gets a flyby, Pluto, if you will, and we all of a sudden now learn that it's not just a blurry little dot in space. It actually has a heart-shaped image on it. It's got a reddish color to it, and we will learn a lot more about it. So tell me what you think. What's your take on this breaking space news?
Yeah, I'm pretty excited about it. That thing's been traveling for 9 years now, over 3 billion miles, and it's going to pass 7,000 miles away from Pluto's surface. Now, Pluto is much smaller than even our own moon, but just to be able, if you think about it, just the technology required to send a spacecraft that far over that many years and get that close is just amazing. And, you know, there has never been a country that has existed on this planet that's been able to do that, except for the United States of America. So I think, you know, our citizens need to really be proud, you know, that they live in a country that is capable of such great feats.
Scott Kelly, I got to tell you, it's amazing to see what you're doing, because if Americans are paying attention, you're about a third of the way through a year-long stay aboard the ISS. You've got about 200 days to go. You look great, but how are you feeling, and how is it to be up there for this long?
You know, in general, I'm feeling pretty good. You know, it's a pretty nice environment up here. The one thing that can be hard to deal with is you can't leave. It's the kind of the isolation factor. But from a human health and performance perspective, with regards to the exercise and everything, yeah, we you know, we have it pretty good now. Being a third of the way through, it feels like I've been here a long time, but I still have much longer to go. But you know, I'm very optimistic it's going to go well.
Now, there's some idea of what might happen to the human body for a year or an extended time in space. I know you've got to work out 2 hours a day, and the data from this flight may actually change or shift the way we send astronauts and for how long into space. So let's talk a little bit about what you've noticed about your body and about your energy and about your mood.
Well, you know, you do get maybe more exercise for some people than they do get on Earth. So in some respect, you're in a little bit of a better condition from maybe a cardiovascular or you know, strength perspective. And those are the things that you can see. But there are also the effects you don't see, like you know, the effects on your you know, your DNA, your RNA, stuff on a much smaller level from the results of radiation or the microgravity environment. There's effects on our vision. There's effects on our immune system. But you know, overall, I feel pretty good. You know, the atmosphere on the space station changes sometimes with regards to the CO2 levels we have, and that you know, has some negative effects. But you know, we work very hard at keeping those levels down as much as we can and mitigating those kind of effects. But you know, overall, I have to say, having been here for over 100 days now, with like you said, 200 days ahead of me, I feel pretty good and pretty optimistic about the path ahead.
You know, it's funny because we think that the entire your environment will be controlled and completely regulated, that you would have the optimum amount of oxygen and the optimal amount of water and the optimal amount of CO2. We just think that all those things would be taken care of. It's very interesting to know that you still are there, trying to figure out what's right for you guys in space.
Yeah, so this is, it's a very isolated environment, and, we get, we're supposed to get regular resupplies. We've seen this last year that there have been some challenges with that, and, we have to live with them. Because of the remoteness of this place and the speed we're going around the Earth, we have to make our own water. We can't expect to get water from the Earth at any time. We do that, taking the condensate out of the air and using our urine and turning it into water. And that's a very, very sophisticated process. It's very complicated. And it's not always, it doesn't always work perfectly. We have to tweak it every once in a while. But it's, really an amazing capability we have. The same thing with electricity. The power on the space station, the electrical power is produced from the sun. And that's also a very, very complicated system. And I think we do a great job at controlling it, and it's something we're going to need to know how to do as we travel further away from Earth.
Let me just ask you personally about this. So we saw the failed SpaceX missions, and we know, talking about your supply line, that interrupted the supply line for a while. And I don't know whether it was real, but there was some conversation and concern about having to evacuate if supplies weren't gotten to you. What's the personal feeling that you have when you're watching that all play out?
Well, there was a lot of stuff on there that we needed. Some of it was very expensive. We had an international docking adapter that is important to the space station that we were going to install here in the next few months that allows commercial crew vehicles to dock to the space station. We have another one, but we wanted to have two so crews could do what's called a direct handover, see each other as they're changing out on board the space station. We had some filters that are important for our water, so we need to manage how we produce our water a little bit differently to keep the quality high enough for us to drink. There were personal items on there, but the good news is all those things can be replaced. They're just things; they're not people. And with this SpaceX vehicle, perhaps you can look at it as a good thing, because maybe we'll learn something from that before we start putting humans on a SpaceX vehicle. When we start flying astronauts to the space station from the United States. So, there are downsides, but there are also potentially positives to it as well.
Just quickly, we follow your tweets here at the Weather Channel. Just a favorite picture so far, or something you're looking forward to shooting?
It's interesting. The other day I was realizing, I think I've taken a lot of great pictures, and every time I think, well, maybe there's nothing new to get. I'm pleasantly surprised. So, I look forward to the opportunity to get some, future amazing shots of Earth, and so far it hasn't disappointed. So who knows what I'll see here in the next couple hundred days.
We wish you the best, sir. We are watching your every move. We're following your every tweet, and we hope this is a complete success for you and for NASA. And we just want you back home safe and sound, sir. So thank you for taking some time.
Oh, my pleasure. Thanks for talking to me today.
Station, this is Houston ACR. That concludes the Weather Channel portion of the event. Please stand by for a voice check from CNN International. Please stand by for a voice check from CNN International.
Station, this is CNN International. How do you hear me?
I hear you loud and clear. How me? I hear you loud and clear. How me?
Hi there. It's Robin Kerner here. You've been up there a few times. What's different this time?
When I got here, I was surprised at how, familiar the environment was, how the space station didn't seem to have changed a whole lot. The size and shape and the condition of most of the hardware was pretty similar. So it was a pretty pleasant surprise. The big difference is I'm just going to be here a lot longer than I was last time.
Well, tell us about that. You're going to be there for a year. What is it about your trip, your length of stay, that is just so important? It's about analyzing how your body reacts. Is that correct?
Well, we've been flying in space, for many years now, and our experience base on the space station from a U.S. perspective has been a little bit over 200 days. The Russians had flown, flights of a year or a little more on the Mir space station, but that was many years ago, and back then we didn't have the same technology. Not only the Russians didn't, but the United States didn't as well, with regards to our ability to collect data on ourselves about how our bodies are affected for long periods of time in space. And there are negative effects, but we need to learn what those are. We need to learn if there are any cliffs out there, if there's any a length of stay that has such a negative effect that it becomes drastically worse at a certain number of days in space. And that's what we're doing. We're trying to learn, what those things are, what the effects of the radiation environment, the microgravity environment is, the effects on our cognition and our ability to perform. So it's a pretty big science experiment, and it's very important to our future to go further and further away from Earth.
I want to talk about that in a moment, but the specifics, how are you feeling this? What are you expecting to feel after a year in space? And simultaneously, your twin brother on Earth is also being checked and poked and prodded. Give us a sense of this massive intergalactic science experiment that's taking place.
Well, there are the effects on this environment that we notice, and then there are the effects that we don't notice, and you can only learn what those are or understand them by collecting data. And the ones you notice are effects on your vision. You notice at certain times, especially early on, a fullness in your head. You notice effects to your digestive system because that uses gravity. Is important to that. Physically, you feel, after a while, you feel pretty good. You have the opportunity to exercise fairly often, which is important. But like I said, there are the effects you don't see, and those are the effects of radiation on you. On a genetic level, the loss of bone mass that we experience. Structural changes in our eyes, for instance, effects on our immune system. And that's one of the reasons why, or, the main reason why Misha and I are here for so long, to understand those. And then you mentioned my brother, the fact that we're both identical twins, and NASA has a long history on us. And with regards to our medical data, it was a perfect opportunity for them to collect data on my brother and also on me while I'm here, and compare the two of us on more of a genetic level with respect to any damage that might occur to my DNA and RNA compared to his experience on Earth for a year.
And is this all about future missions to Mars?
Well, I wouldn't say it's all about that, but it's definitely about understanding how to live and work in space for longer periods of time. Who knows what our future holds? I think Mars is definitely in our path, in our future, but perhaps elsewhere. And this is the space station program, and our collective history in space is a start, and this is another stepping stone to understanding how to live and work in space for longer periods so we can go further from our planet.
Talking about going further from our planet. We've been seeing images of great celebrations at NASA, the first space probe ever to fly by Pluto, seeing some extraordinary photographs. What do you make of this? What's your reaction to that?
You know, I'm just so impressed and, proud to be part of an organization and part of a country, a citizen of a country that can send a spacecraft over that distance, 3 billion miles over a period of 9 years to a planet that is much smaller than Earth's moon and fly within 7,000 miles of it. And, it's just amazing. And it's an achievement that, no country on Earth has ever been able to accomplish before. And so it makes me just proud to be an American today. And I think, the people at NASA that's worked on this project for so long really need to be congratulated. And I congratulate them. I think it's an incredible feat.
Of course, there are many questions I would want to ask you, but we also put it out to Twitter, and we had some questions that ordinary people here back on Earth want to know. And 2 young boys asked their mum to ask me to ask you, how do you brush your teeth on the space station?
There's a couple methods. There's no sink here, so it's not like you can fill your mouth with water and spit the toothpaste down the drain. Some people spit it out into they brush their teeth with with toothpaste and maybe some water, and then you have 2 options. One, you can spit it into a towel, which is somewhat messy, or into a napkin. The other is you could swallow it. And I would not recommend to any kids swallowing it or any person swallowing toothpaste for that long a period of time. But, I'm one of the people that just swallow it. I don't know if there are any negative effects to that, but I've been doing it for a long time, and it so far hasn't hurt me too bad. But it's not, I wouldn't recommend it.
And I'm sure some of these kids would also be interested to know how you make your own water up there on the space station.
Yeah, so we have a very sophisticated system that takes the humidity in the air, and it also takes our urine, and it processes it through a condenser kind of system and some filters. And it turns it into drinking water. And surprisingly, when we turn the urine into drinking water and we turn the humidity in the air into drinking water, the urine actually makes better water than the humidity for some reason. But it's great water. It tastes better than the water that comes out of the sink at my home in Houston, Texas, and I have no problem drinking it. And it's a great capability we have here, and it's a capability that's been have spin-off technologies on Earth in areas that are very water critical.
Another Twitter question: why are you wearing 2 watches?
Yeah, so, one's a watch that has the time we use, which is Greenwich Mean Time, on board the space station. It's got a nice alarm. It's got a light that you can see around a little bit. But the other watch is a sleep study watch that measures light, and it measures acceleration, so it can tell when I'm moving. So it basically can tell when I'm asleep. And, people have issues sleeping in microgravity or in, probably stressful, high-stress environments for that matter. So this is part of a scientific study to just measure how our sleep is conducted over the period of the course that will be on board.
Thank you very much, sir. Good luck.
Oh, nice talking to you today.
Station, this is Houston ACR. That concludes the event. Thank you.